Okay, so for the first little bit, like don't write anything on their paper right now. We're going to look at what needs to be there, and then we're going to score some together, and then you will score that section on your page. All right? All right, so on section A, the model solution was the scatter plot reveals a strong, positive, roughly linear association between the mass and length of bullfrogs. There are no points that seriously deviate from the straight line pattern of the points in the plot. Things that you need to have. You have to have at least 3 of these 4 components, and you have to have component 5, which is context. So you have to have direction, positive or increasing, one of those words or something to indicate that. They could say as one goes up, the other goes up. That would indicate a positive association. Strength of the association. I would accept strong or moderately strong. If they just write moderate, that's an adjective. That is describing either strong or weak, but moderate by itself would not work. Form of the association, linear or approximately linear. If they say linear, that would be okay, even though that is kind of that language that we want to soften up a little bit with approximately. Unusual features. They need to point out that there aren't really any large discrepancies. There's no huge unusual features. Yes? I would not count outliers, because outliers are specifically, like, we have a straight definition for outliers that's 1.5 times the IQR. But if they use the word outliers, and they talked about there not really being any outliers, but they have direction, strength, and form, I wouldn't count off on that. They have 2 of the other things. Okay, we'll look at the scoring and talk about what you're going to get them. Yes?
They don't say that the linear relationship is strong. They say like no strong skew. Is that okay?
No, that would not be the same thing. That would not be the same thing. All right, I want to look at just a couple examples here. We're going to score these together. Here is one student's answer. There appears to be a moderately strong linear relationship between mass and length for the 11 bullfrogs. There are no obvious outliers. How would you score that? Yes, 3 things in context. Remember, you have to have 3 of these 4, direction, strength, form, unusual features. Remember, that's our duffs. And you have to have context. As long as they get 3 of the 4 plus context. They have moderately strong, that's 1. They have linear, that's 2. They have there are no obvious outliers, that's 3. And they have our context between mass and length for the 11 bullfrogs. There are no obvious outliers. Yeah. I would take that, sorry. If they said outliers on theirs, yeah, let's go ahead and give it. Because this got an E. This got an E. All right, let's look at a couple more, and then if you guys have specific questions about yours, I'm more than happy to help you with the scoring there. The mass and length of bullfrogs have a linear positive relationship. That is, as length in millimeters increases, mass in grams increases as well. There seem to be no extreme outliers. E. They got direction. They got linear. They talked about unusual features, and they have context. That's an E. All right, third student's example. There is a strong positive relationship between length and mass. As the length of a bullfrog increases, the mass also increases. P. They got strength. They got direction. They got context. So that would be a P. So I want you to look at yours. Partially correct if they only get 1 or 2 of these top 4. So if they just said it's approximately linear, but they used context, that's still a P. So if they got 1 or 2 of these plus context, that's a P. Or if they get 3 of these, but they leave out the context, that's another way that you can get a P. Yeah, if there's no context and only 2 of these, that's an I. I'll be around. I would take that as context, yes. All right, Brandon, you had your hand up? Did you want me to look at one with you?
Oh.
Moderately strong, linear, no clear outliers. The longer the length, the higher the mass. There's your context in that last statement. That's an E. Yep. All right, does anybody else have questions about scoring part A? So remember, question number 1 on the AP exam is always going to be describing some type of either linear relationship like this using Duff's, or like a scatter plot, a box plot, whatever, using SOCS. So you're going to use either Duff's or SOCS on question number 1. That's like, I won't say 100% because this is statistics, but how about we go with 95%? All right. Part B says to identify and interpret the slope of the least squares regression line in context. Scoring guidelines for part B. Model solution, the value of the slope of the least squares regression line is 6.086. This value indicates that the predicted mass of a bullfrog increases by 6.086 grams for each additional millimeter of length. You need to have all 3 of these on your paper to get an E. You have to identify the value of the slope as 6.086. You provide an interpretation that references an increase in the number of grams of mass for each 1 millimeter increase in length. Notice they did not use the word 1 over here, but they said each additional, or for every 1 more, for each, for every. That would work. Part 3 indicates the slope represents a change in a prediction using non-deterministic language such as predicted, estimated, expected, or average. There has to be something in there that indicates that this is not a guaranteed outcome. This is a predicted outcome. Partially correct if they get 2 of those 3 components. Incorrect if they get 1 or none of those components. So let's look at a couple student work samples. And then I can put this back up so that you can score the one in front of you. So here's student number 1. The predicted mass in grams of a bullfrog is expected to increase by 6.086 for every 1 millimeter increase in the length of a bullfrog. E. They did not say the slope is, but they are clearly identifying what the slope is in context. And they are interpreting it correctly, so that's an E. The slope is 6.086. This means that for every 1 millimeter increase in length, mass increases by 6.086 grams on average. E, they saved themselves with that on average right at the end. If they had not added on average, it would be a P, because they would have deterministic language instead of that non-deterministic language. Student 3, slope 6.086 grams per millimeter. For every 1 millimeter increase in length of a bullfrog, there is a 6.086 gram increase in mass of the bullfrog. P, because?
He used deterministic language.
Didn't use non-deterministic language. If they'd used average, expected, predicted, anything along those lines, this would have been an E. But because they left that off, it's a P. All right, go ahead and score the paper in front of you on part B. They need to have all 3 pieces for an E. 2 parts is a P. 1 or none is an I. If you have any questions about how to score the one in front of you, please let me know. Is everybody done with that section? All right, yes. I'm sorry, you had your hand up. Mass gram for every 1 increase in mass. Okay, so they identified the slope. They have context, but they flipped it around. I'd give them a P. All right. Part C. On part C, we need to interpret the coefficient of determination of the least squares regression line. R squared equals 0.819 in context. So they're telling you what the coefficient of determination is, and they're referencing it symbolically. That is R squared. Model solution for this. The coefficient of determination is R squared is about 0.819. This value indicates that 81.9% of the variation in bullfrog mass can be explained by variation in bullfrog length as described by the least squares regression line. To get an essentially correct, the response provides a correct interpretation of r squared in context. So you would have to have 81.9% of the variation in bullfrog mass can be explained by the relationship or the variation between length or with length by the least squares regression line. Partially correct if they provide a generic interpretation but no context, so no mass length stuff or millimeters grams, that would be enough for context there. Or if the response provides a reasonable but incorrect interpretation of r squared in context, they would get a P. Incorrect if it doesn't meet one of those two criteria, either for an E or a P. So let's look at some student work samples to see what a correct answer looks like and what a partially correct answer looks like. Student 1, 81.9% of the variation in the mass grams of a bullfrog is accounted for by the least squares regression line on length millimeters of a bullfrog. E. That would get an E. Student 2, 81.9% of the variability in predicted mass is accounted for by the least squares regression line. They got an I. They got an I on this part. I'm trying to figure this one out myself as well. Why did they get an I, but they got an E? 89% of the variation in mass is accounted for by the least squares regression line because they don't have the response variable there. They have only one of the two variables mentioned. So they did not provide a complete explanation of what r squared is. While they did use context, they didn't have both variables here. You're talking, r squared is talking about the relationship between the explanatory and the response variables. All right, student number 3, the typical discrepancy between length and mass of a bullfrog is approximately 0.819 grams per millimeter. That's an I. That's an I. The typical discrepancy between length and mass of a bullfrog, that's like standard error, right? This is talking about, so it's not talking about discrepancy. That word discrepancy is throwing things off right here. Because there's not a discrepancy necessarily between length and mass. We could calculate a residual that would be the difference between predicted and actual, but we don't have discrepancies between length and mass here. So that would be an I. All right, so I'm going to put the model solution back up. E, P, or I. If you have questions about how to score your student's page, please let me know.
The error between bullfrog length and mass is captured by the
I, unfortunately. Unfortunately, because they don't have, let me see. Yeah, they don't reference the variables, unfortunately, so that's an I. Amount of variability accounting for the least squares regression line. They don't talk about the second variable, I. Does anybody else need help scoring this one? This is, in my opinion, one of the harder sections on this question. All right. Part D. Part D. Part D had two parts. Based on the plot, approximately what is the length and mass of the bullfrog with the largest absolute value residual? And part II, does the least squares regression line overestimate or underestimate the mass of the bullfrog identified in part DI? Explain your answer. What do they mean by this largest absolute value residual? Yeah, it doesn't matter which one is the farthest away from the line. That's what they're looking for here. They don't care whether it's farthest away above or farthest away below. Which one is the farthest away? Model solution for part I. The largest residual in absolute value belongs to the bullfrog with length 162 millimeters and mass 356 grams. Let's go back and look at that graph again. Obviously, you can't say exactly 162. If they have something between 160 and 165 for the length, that would be okay. As far as for the mass, if they have something between 350 and let's go 370, 375, I would be okay with that. Because again, we're ballparking. This is not hitting it at an exact spot. So anywhere from 160 to 165 here. Anywhere from 350 to 375. For II, the least squares regression line overestimates the mass of the bullfrog with length 162 millimeters. Plot 2 shows that the point for the bullfrog with length 162 millimeters is below the least squares regression line. 2 components to get an E. The response to part DI identifies the correct bullfrog, length between 160 and 165 millimeters, mass between 350 and 375 grams. They have to be specific on both counts so that you know which dot you're looking at. So it's kind of like referring to it by an XY here. The response to part DII explicitly indicates whether the linear model overestimates or underestimates mass for the bullfrog identified in part DI and provides a correct justification based on a comparison of the identified observation to the least squares regression line. So you have to state whether it's an overestimate or an underestimate, and you have to provide justification because it's below the line, because it's above the line, or the line is above the point, the line is below the point, something along those lines. If they incorrectly identify the point here, but for the point they reference here, they correctly describe it here, that would be a P. Partially correct if the response satisfies only one of the 2 components. So again, if they incorrectly identify here, but their rationale here is correct, that would be a P. Or if they correctly identify this, but they botch part DII, that would also be a P. Let's look at a couple student work samples. Student 1, the bullfrog with the largest absolute value residual has a length of approximately 162 millimeters and a mass of approximately 355 grams. The least squares regression line would overestimate the mass of the bullfrog because the bullfrog has a negative residual with the observed value being less than the expected. E. That would be an E. Student number 2, the bullfrog with the largest absolute value residual. Do you notice the parroting back of that stem? Please do that because that's a good way to get your context in there. If you parrot the stem back, you're almost guaranteed to get context. The bullfrog with the largest absolute value residual has approximately a length of 162 millimeters and a mass of 351 grams. The least squares regression line overestimates the mass of the bullfrog because with a length of about 162 millimeters, it predicted the mass to be about 440 grams. 440 grams is greater than the observed value of about 351 grams. E. E. They provided justification by referencing the predicted value on the line. So they didn't say the line is above the point, but they did talk about the predicted value being more than the observed value. And last one. Length, approximately 162 millimeters. Mass, approximately 352 grams. The least squares regression line overestimates the mass of the bullfrog because the line is above the point on plot 2. E. These are all E's here. Take a moment to score yours. And if you have questions about how to score it, please let me know. Overestimate, because using least squares regression, the mass was blank when the actual was about this. Predicted mass. I'd get that in E.
So this is wrong, answer, but would you say like the reason for where the answer last code would be?
So they said 171, 525. So they pointed out this one, and they said that would be an underestimate because there's evidence that the residual of the bullfrog is larger due to the graph.
Is that correct?
They didn't give quite enough here. They could have said the point is above the line graph, or the point is above.
So even though the point that they pointed out was incorrect,
they could have gotten this one if they provided just a little bit more, and then it would have been a P.
is it not a P?
It is not a P, it's an I. 162, 300. It overestimates the mass of the identified bullfrog by about 89 grams. I give them a P. I give it a P.
But is that okay?
Approximate positive linear. Yes.
Okay.
Yep.
And then I know this one's wrong.
Okay. It overestimates the mass of the bullfrog. Since the mass is this, the line should be lower to. I give it an I. Yep. All right. Let's look at the final scoring bit with our last couple minutes because I want you to give them a score of 0 through 4. Each E counts as 1 point. Each P counts as a half a point. If you come up with like 2.5, we're rounding down. So if you get a final score that is on a half, round it down. Each E is a 1. Each P is 1/2. Yes. If they get a 1.5, that would round down to a 1. 2.5 would round down to a 2. 3.5 would round down to a 3. Once you are finished putting the score of either 0, 1, 2, 3, or 4 on the paper, please go ahead and close it, find the name on the front, and return it to that person. Thanks. Damn. Okay, I did check that all the papers had names.
And yeah, because when she was explaining the correct answer, when she was explaining the correct one, I was like, dang, I hit this one, not this. And then the one where you write it, like, you write it on one side, like, these ones are connected,
So tomorrow we're going to do something similar. One of the things that I'm really hoping we take away from this is you guys are seeing exactly which things have to be included in your answer and what little pieces will knock you from an E to a P or a P to an I. So that hopefully when you go to take the actual AP exam, you're remembering all those little nuances and you also don't talk yourself into a lower score. Just because they give you a ton of space does not necessarily mean that it's a lengthy answer. Sometimes they just didn't have room to fit it on the previous page. So you got a whole page for one sentence. Don't talk yourself into a wrong answer. Okay, I'll hang on to these two and then tomorrow.
I won't be here tomorrow.
We'll do Thursday then.
I realized there were just little mistakes.
That killed you?
Yeah.
Yeah. Funny enough, that's what we're talking about in this group.
But it didn't.